Hello, Cappuccino. Here are some notes about the Pythagorean theorem. So in class, we did an investigation where you were given some tasks to do, and we discovered that there is a relationship between the sides of the right triangle. All right, so what this asked us to do is if you have a right triangle, and they gave us some side lengths, they said this side's 3, this side is 4, and this side is 5. And they said, if you draw a square on the side of each triangle with that side length, so this would be a 3 by 3, this would be a 4 by 4, and this one would be a 5 by 5, that something interesting happens. So the area of this one right here, of this square, that's 3 by 3, that has an area of 9, okay? And if you're a little confused about that, remember this is 3 units long, so I can break that into 3 units. This side is 3 units long. And if I drag across here, and I cut it up into squares, you can see that there are 9 square units. So that's what we call area, how many squares fit inside the shape. So this has an area of 9. And then we do the same thing with the one that is a 4 by 4. So this side's 4 and this side's 4. So this is going to have an area of 16. So the fast way of getting that answer is just multiply the sides together. 4 times 4 is 16. 3 times 3 is 9. Okay, and then the third square is a 5 by 5. And if we multiply those together, we get the area is 25. So if we add this area plus this area, if we add 9 plus 16, 9 plus 16 is 25. And notice that's the same thing as the area of the big square. Voila. So this is a relationship that always exists when you have a right triangle. If you take the two short sides, and those are the sides that make up the right angle, and you square them, you find the area of the square along those sides. If you add them together, they equal the area of the third side. So there's a formula. Instead of using numbers, we could use letters. So if I have a right triangle, and here's my right angle, I can label one side A, another side B, and then the longest side, which is called the hypotenuse, we're going to call that C. So C is the hypotenuse. The hypotenuse is always the longest side. It's also across from the right angle. Okay, C is the hypotenuse. It's the longest side. So when you have this situation with a right triangle, we know that if you take this side length, A, and you times it by itself like we did here, and then you take this side length B and you times it by itself. Notice I'm writing that as B squared. That means B times B. A squared, that means A times A. It's going to equal this side times itself, C squared. So this is super handy when you have two sides of a right triangle and you're trying to find a missing side. So, for example, if I have, let me see, find an example. Let's just make up one. So if I have a triangle, and I know that it's a right triangle, and I say this side is 5, and I know this side is 12, and I want to find the longest side. Well, I can use this formula to figure that out. So these are the two short sides. So I know this side times itself plus this side times itself has to equal the long side times itself. I don't know what that is yet, so I'm just going to put the letter C, because that's what we call the hypotenuse. We just call it C, the long side. So 5 squared is 25. 12 squared is 144. And if I add 25 plus 144, I get 169. Now, what number times itself is 169? I happen to know the answer, but not everybody does. So this is where a calculator comes in handy. So on my calculator, here's where the squared button is, x squared. But if I want to go backwards and figure out what number times itself gives 169, I'm going to actually use the little symbol that's right above it. And in order to get that, I need to use the second key. So I'm going to hit second and then the x squared. And notice it gives me the square root symbol. So C is going to be equal to the square root of 169. That's the symbol that we use to figure out what number times itself equals a given number. So I'm going to put in my 169. So I'm taking the square root of 169, hit enter, and it's 13. So that longest side is 13 units. And that seems reasonable because it's just a little bit longer than this long side. Okay, so that's using the Pythagorean theorem to find the missing hypotenuse. Well, what if I know the hypotenuse and I want to find a missing side? So let's do one of those. So I've got myself a right triangle. And let's say I know that, oops. Let's say I know that this side is 6, and I know this side is 10, and I don't know this side. Well, I know that this side squared, and for this one, I'm going to actually draw out the squares just to make it so you can see what I'm doing. So I know this area is going to be 6 times 6. So this is going to have an area of 36. This area, if I draw a square here, it's going to be 10 by 10. 10 times 10 is 100. But what is going to be this area? Well, I know 36 plus this has to equal 100. So 36 plus something has to equal 100. Well, to figure that out, what I can do is I can just subtract the 36 from the 100, and that'll give me the area of this square. So this missing area, I can get it by doing 100 minus the 36. So if I do that, if I do 100 minus the 36, I get 64. So remember though, that's the area. That's the area. This has an area of 64. But now I need to figure out what's this side length here. What's that side length? So I'm going to have to figure out what number times itself is 64. So remember how we do that? We take the square root of that number. Okay, so the square root of 64, I happen to know what it is, but if you don't, again, use the calculator. Second, x squared to get that square root symbol, and then 64. And I get 8. So my answer is 8. So this missing side here, the side that was missing, oops, sorry, the side that was missing there at the beginning is just 8. So this was 6, this was 10, the missing side is 8. Because 6 squared plus 8 squared is going to equal 10 squared. Okay, so here's our check. I'm basically checking my answer here. 6 times 6 is 36. 8 times 8 is 64. 10 times 10 is 100. 36 plus 64, 36 plus 64 is also 100. So you can see it works. All right, that's it. Very simple. Pythagorean theorem. The 2 examples, what do you do if you're trying to find the missing hypotenuse? That was this one. If you're trying to find the long side that's missing, versus what do you do if you're trying to find one of the short sides? Okay, so the difference is here, when you're trying to find the long side, you end up adding the numbers squared together. But here, when I was looking for one of the short sides, I was missing a short side, I ended up subtracting these 2 areas. So that's the thing to notice on that one. All right, I hope that works for you, and see you later.